to begin implementing the observer pattern into this Rust game. Now, what we learned on Friday, in case you weren't here, you didn't see that VOD. It is possible to pass essentially an instance, like what looks like an instance of the object around. It's not quite exactly that because Rust won't let you truly have two mutable references to an object at the same time. So it's really one reference to an object, and it's being protected at runtime by arc mutex. So what we want is some traits that are gonna basically describe what type of what the entire event system really is. So let's go ahead. Now these are going to be generic traits for us. So I'm thinking we're just going to want a traits.rs. Maybe even not a file. Maybe we want like a folder with utilities. And inside of that, we could just have our traits.rs. And so we're going to have a public trait subject. And we're also going to have a public trait. What was it? It was the observer. So in the subject, we know that there's going to be an add observer. So function add observer. We know that this is going to require a mutable self. We're also going to have an observer. And this is going to have to be a type, I guess. So this might come to like another utility here is we want the events. Like what the specific events are, which can be a... we did discover this. We can do a enum for that. We can do an enum, or we can just do plain strings. Let's try an enum first. So this will be our events. Now thinking about this, I do events.rs. I kind of wonder, let me rename this. Instead of utilities, let's rename this to events. Events can be, rename this to a mod.rs. I don't actually know if I'm gonna need to put, like, to keep these separate in a separate file. So if I delete you, go straight into mod, we're gonna have public trait subject, public trait observer. Are you upset just because I haven't created a function inside of you yet? Or no, because I haven't finished this. And we're gonna have a public enum event. All right, so what are the different events that we can have? Well, the one we have right now is player jumped over obstacle. I mean, and that's kind of it. We just don't care about storing anything in it. We just want to know that that happened. Okay, so then this is going to be observer. Oh, right, but the observer. Oh, okay. It's not. We can have event, but we still need an observer enum. And the observer enum is aware of all the different types of observers. And this is the equivalent of using like interfaces, where an interface is a type. Unfortunately, that doesn't really exist here. So in Rust. So we're going to do a public enum observer. Now we have a trait observer. So this is going to be a this is gonna not work. I wonder if I could just possible observer. Yeah, naming things is hard here. I'm not sure what I want to name this. I don't really like possible observer. Observer, I don't want to say like observer trait. I don't know. I'll implement it as this right now, but I'll have to probably figure this out. All right, so then for the possible observer, we know for right now that score is going to be an observer. So we're going to have a score. Actually, would this be a struct? To wrap around which observer it is. Because I'm thinking about what if I want to, okay, so I need to store an arc and mutex. We ran into problems when we were attempting to do this with generics. Although that would be nice if we could eventually do generics with this. But we did run into problems when we attempted to implement that fully. There's more to learn with generics for myself. If I want to wrap around and basically have, okay, so score is gonna watch an event, and then who else is gonna watch the event? Possibly the main game state. Yeah, the game state is gonna watch the event too, so that way it can change itself to be something like, I'm not playing anymore. It can then like be intelligent about, okay, what screen are we on now? That's an enum too. Oh man. Where was I? You're in our mod. All right, so if we have score, we need to wrap the score in. So if I use this as just like a tuple, so score, let's bring in score. But this wouldn't be a score, would it? It would be an arc mutex score. So it would be an arc mutex score, like that. And then we can add in like another arm to this whenever we have another type of event or another possible observer. Okay, so if we do that, then our observer is going to be a possible observer. We'll consume this possible observer and add it to this self, the self right there. So I think that's fine, and we won't return anything. So what else do we have? We have add observer, and we have notify. So function notify. I believe that we learned that this has to be a mutable self, even though we're not mutating ourselves. Just dealing with arc and mutex, kind of we are mutating ourselves. We're mutating the arc to get stuff out of it. That's part of the safety provisions here. Okay, so we have notify. And what? I guess it's going to be the event, which is going to be a type event, or this enum event coming in. And then we will we'll let everyone know, hey, here's this event. So I think that's going to be that for that. And then observers, we're going to have a function on notify. And this is going to be mute self and the event coming in. And that's pretty much all we care about here. So I think this is the beginning of how we're going to be able to do this. Now, something else that I've learned is if we don't want to use this everywhere, which we may not want to because that can be a little bit tiresome to throw that in there. There is a way that we can do type, and then we can name the type. So we're gonna name this the, what should we name it? Wrapped score. And that is an arc mutex score, like that. And now I can say, okay, score is going to be a wrapped score. And now I can use this everywhere, and it's basically just, I mean, it is this now. It's an alias. Okay, so this gives us like the basics, and now we can pass this around and implement the observer and the subject wherever we want to. So in our main library, let's go ahead and mod this in. So mod events, and I believe then it will just call mod straight off of here. So use, also, what are you upset about? Nothing. Okay. Use, oh wait, you were upset. Oh, cannot find, right, so we have to use, what is it? It was standard sync arc and mutex. Right, so now it's just going to complain that we haven't used it yet. That's not a problem. Okay, so back to library. We modded the events. Here, that is here. Now we're going to use it. So use events. So let's grab out of here event, observer, and what was the last one? Subject. And now we can sort of pass those around and use them wherever we want to. Specifically, we're re-exporting them so that, you know, further deeper in we can end up using them. So we remember that obstacles is the one that is determining whether or not the player has jumped over the obstacle. So the obstacle is going to be our subject. So let's go ahead and implement impl will bring in the traits. So use player super at the top. It's not just player anymore. We need to bring in the event. We need to bring in the subject. And I believe we need to bring in the observer. We need to bring in all three of them because, well, we're the subjects. We need to impl subject for, you know, obstacle. We need to send the observer the event when that happens. And then most importantly, we need to store a list of our observers. Let's go ahead and impl subject for observer. And so now it should yell at us that we haven't implemented, let's see, add observer and notify. So function add observer, self, and nothing ending there. So, and then notify itself, and the event comes in, and we do stuff with that. Okay. Ooh, possible observer. Can't find possible observer in his scope. Right, I had the event. the observer. Oh, so I don't think I need the observer trait. I need the possible observer. What was that? This possible observer is a wrapped score. Actually, I don't. No, okay, we do need this for the future other things. I keep on like going back and forth. Do I really need this? I think that's only because I didn't practice with it. So we need the possible observer 2 out of events. Possible observer, which will allow me to come into obstacle and grab that up here. Possible observer. That will make you happy, and okay. All you're doing now is just yelling at me that I haven't, nothing's been done. Trait objects without an explicit dyn are deprecated. Trait objects. Wait, where am I doing a trait? I mean, so it wants me to do dyn observer? Isn't observer just the trait? It is just the trait. But I wonder what. I don't think I needed to use dyn in the practice code. So I wonder what I did differently here. The main thing is this enum. And so that might be the big thing. Anyways, let's come back to here. So when we add the observer, we're going to, so somebody's going to call add observer on us, probably that main game, and hand us a possible observer. So that will be the game state. No, it'll be the main library here. When we initialize and we set up the observer, we'll immediately add in the possible observer at that point in time, which means that here we need to store it. So we also need to bring in that type. Possible observer should be it. So public struct obstacle, we're gonna do observers, and this is gonna be a type. It's gonna be a vec of possible observer. And so now you're yelling at us that we don't have that, so let's fix that. Possible observer, no. Oh, right, observers. Equals a empty vector. I mean, I suppose we could bring in observers right away, but I think it'd be best to have initialize the obstacle and then add the observers afterwards. And then we're gonna just store in the observers here. So that should make you happy. You're just not being used. So then here, we're gonna say self.observers.push observer. We're gonna consume that observer and own it. But it's fine. The possible observer is an enum. That's going to have to be copied or cloned. What are you? No field observers on type. Mute dyn events observer plus static. Self dot. Okay, so we have observers there. Now you're upset because obstacle, not observer, obstacle. That's why it was going weird and why I was getting confused. It's like, what? I was trying to implement a trait for itself, or at least a trait for another trait, which apparently that is doable. I didn't know that at all. or at least the fact that I was attempting to implement a trait for a trait, did not seem to upset it too much. It was more of that like, hey, it needs to be dynamic now if you're going to do that. All right, so that's going to allow us to add an observer. Let's go ahead and actually wire this up and get that observer in here. So if we add the observer in our main library here, we're going to have to get our observer. We know that observer is a possible observer that's really a score. That's a wrapped score. And that's it. Are all these exported here? I think I need to make this public too so I can export it, so I can get the wrapped score out of here. I think so. I don't know. I may be wrong. It'll yell at me if I don't end up using it. Okay, so here in our game, we've created the obstacles here. We want to now add the score in. So when we create our score, here this is, we're going to wrap this in an arc mutex and then throw a clone of that into the enum. So we also need to bring in arc and mutex. So use standard. I'm not using standard anywhere else. Sync arc mutex. So here's our score. Let's go ahead and wrap that. So it's going to be an arc mutex score new. And what are you upset about? Use : instead of to specify type arguments. Oh, right, I forgot. It's when I'm creating it, it's arc new. So we're gonna do arc new, mutex new, and then inside of here, we're finally gonna have a score new. This gives us our full score. Okay, so we have our score. I now want to register. Well, okay. We also have to like store the score, this like clone of the score in this arc mutex. This is where the wrapped score comes in because our score is going to be a wrapped score. And that'll make it happy down here. In fact, I may want to change this name to a wrapped score just because it'll make it both easier to find where we're using it, and also it makes the name a little bit more understandable. What's going on? So we have that. Let's now register the we need to create the enum. So we have our score. Immediately after this, we're going to do let. So this is going to be the score observer equals a possible observer score, and we're going to clone score and put it in here. So you are a wrapped score now. And we're going to clone you. And that just works. I don't have to do anything else to it because I'm cloning the arc. I'm not cloning score itself. There's still only one score, even though now there's two sort of references to it. Cowtel, good morning. Hello. We are implementing the observer pattern today. So learning Arc and Mutex in order to have essentially two like instances that are mutable at the same time, which is kind of a lie, but it's pretty cool what we can do with it. Okay, so now we have our score observer. We can now add this in. So maybe after all this, we're going to, so for our obstacles, we need these to be mutable at this point in time. And we're gonna say obstacle 1 dot, and I think, is it add observer? And then the possible observer here is our score observer. And then we're going to do the exact same thing with obstacle 2. So obstacle 2 dot add observer score observer. What is the highlight of that pattern? Is it a low memory design? It's more of a solid design. So I think it's actually, well, in this case, actually, it's not any higher memory. But what we want to do is want to have the obstacle inform the score without knowing anything about the score. And we don't want the score itself doesn't need to know about the obstacle. So those two structs are basically separate, out here like that. We want the obstacle to be able to just emit an event that says, hey, the player jumped over me. And the scorer to say, hey, I was the one looking for that event. Therefore, I'm now going to increase myself. That's what's going on. It's an code organization. Exactly, it's just events triggering. And so, like, I know Tokyo has an event system, or at least that's what I've been informed. There might be a better way to do event system. I haven't found it. This is as close to the observer pattern as I could come without like being more evil. I don't know whether or not I would like continue using this in real life. I might find like a better way that's not like written from scratch. Okay, so we've added our observers. So that it, and we have some errors. Let's handle those. No field score on type my game. Right, okay, so now we have to, this is gonna be interesting. We're now gonna have to unwrap our score every time that we use it. So here is score text. So we're gonna grab the score text. So we need to wrap score. Let's just do this a little bit of ahead of time up here. So let our score equals, we would need to clone it and then we can lock it to get it out. So it's going to be self dot wrapped score dot clone. So it can't pass by reference because arcs don't do that. So we're going to clone that. And then to make this a little bit more obvious what's happening, I'm going to put this in a block here. And this will also remove the arc from memory as soon as we're done with this. That score text. Oh, we're going to have to create that mute score text just like that. And I'll set this equal in here. So this block is mainly to help us organize this here. Okay, so score self-wrap score clone. Okay, and then we're going to have to get it out. So we're gonna say score dot, I think lock. This is still a wrapped score. So dot lock. Lock acquires the mutex, blocking the current thread until it's able to do so, and then you can essentially just unwrap it. So then unwrap this. And I think this is usable here. I might need to dereference it. Nope. Okay, so that's just happy the way it is. So we have this arc, we have this mutex, we lock it. That's for the mutex. We're saying, hey, mutex, make sure now that nobody else can mutate this. I want to mutate it. So then we unwrap it, and then we get it. And that gives us the text out. You know, thinking about that, do I even need to lock it? I don't know, because I don't think I need mutable reference to it. I think the mutable part is only for getting, like, setting the font. Can I wrapped score dot unwrap? No method name unwrap for this in current scope. Oh, it's like get there's a method for getting so let's see, as ref. There's borrow. I know there's a way to get it not mutable. Can I just like get a I mean, so there's this as ref. As ref might work for me. So as ref like that dot unwrap dot get. I wonder if that would work. No method named wrap for found for reference, center sync mutex, score in a current scope. So maybe there's no unwrap here. Do I need to dereference it? No method name get for reference source interview. Okay, so I haven't like extracted it from the mutex at this point in time. So asref did not do that. So lock gives me a mutable reference to it. I wonder if I can Firefox Developer Edition. Let's see, what is this? This is our no, not book. Standard library. That's what I want. We want the mutex. I want to be able to get mute into inner is poisoned locked new try lock. That's pretty much it. So I guess I can't really get anything out that's not mutable. Like it's gonna have to be mutable. Yeah, and I don't want to consume it either. Okay, so we're just gonna have to lock it. So wrap score dot lock, that gives us out of the mutex, and now we have the arc. Oh no, now we have a mutex guard, and so now we're gonna it's an option. So we're gonna unwrap this, and then we can get it. So there we go. And then as soon as we're done with this scope, it's going to undo that lock again, so that way we can use the lock somewhere else. Okay, so here's this again. So draw score here. We're going to let mute score text, and let's just pull you in. Score text equals you. We first need to get a clone of this. So we're gonna say that wrapped score equals self dot wrap score dot clone. Then I'll be able to do wrap score dot lock self.unwrap. And you are a function too. And then finally, okay, so game state, if game over. So if let command, and then we're going to execute, command.execute, and then we have to hand it the score. What were we doing here? We're doing, if some command, oh, so whatever the command is, execute and hand it, we should hand it the, probably not a reference to, just a straight up wrapped score. So self.wrappedScore.clone. So there are a lot of clones here, but it's not really bad for us. So it's just yelling at us that command execute doesn't take that. So let's go mismatch types. I was hoping it would take me to where it was defined. So execute here. So score is now going to be a wrapped score. And this is going to take, so we need that type. So we're going to use super, what was it? It was the, yeah, wrapped score type. Wrapped score. Like that. And we no longer take in a score. I don't know if you need to be mutable or not. I think you're fine. Okay, so you unused import super score, so we don't need you anymore. Method executable has so implement game command for reset game command. Oh, right. So you are no. So the command trade. Okay, so I updated the command trade. So now in reset game command, we need to update this here too. So this is now a wrapped score with your type being a wrapped score. And we don't need you anymore. So when we call score.reset, we are now going to have to deal with this. And it's going to be the exact same thing as before. No, we do know we have a clone of it. So that's going to be a little bit simpler. We can just straight up at this point in time do a wrap score.lock .unwrap .reset. And that should just work. Used to move value score observer. Right, okay. So score observer is this possible score. We just want to give it a clone of it twice. So let's clone it here in his first one. I'll probably have to implement clone for score observer. Possible observer. So let's derive clone. Okay, so there we go. We're back to working again. It took a little bit of time because we renamed and we wrapped score around. We had to go to everywhere we were using that, sort of update that. But the code is compiling again. That's really awesome. So let's see. We have our obstacles. We've added the observer. We go to our obstacle here. And all we've done now is we've just pushed the observers into our vector. Now, when this happens, when we jump over the obstacle, we're going to call notify and then tell everything what happens. So we're going to do self.notify, and then we have to pass in the event. The event is going to be, so we need to grab event right there. So self.notify and is event. Player jumped over obstacle. Oh, that's it. That's all. So then in here we have notify, mutable self. We have our event. That's this type of event coming in. So what do? We're going to loop through all of our observers and then tell them, hey, this happened. So for observer in, and so this is where it gets a little bit interesting. We're going to clone this array of observers, which again is really cheap for us because it's just a clone of pointers. It's not actually a clone of, like, it's just a vector of pointers. It's not a vector of anything substantial. So we're going to do self.observers.clone. That way we just consume this this vector when we're gridding them, because we do need it to be mutable. And then that gives us our observers, which we know is that entire wrapped observer thing. I guess it's a possible observer. So I should really maybe do possible observer in self.observers.clone. I don't know. Do I have possible observer here? I do. Now we're going to need to match off of this. Are we going to need to? Oh, I think we do, because it's an enum. Although I might be able to do it for any of them. We'll see how Rust likes it. So for each possible observer, we're going to need to extract out what it is. So we could try an if let for a match. If I do, let's try the if let first. So if let, it's going to be the possible observer score observer equals possible observer. And so with this one, we're going to have to like be explicit about, hey, it's a score and we're passing this in. Let's try getting this one working right away, and then maybe we can refactor it to be a little bit better for us. Okay, so if that possible observer score equals observer, now we're going to take that observer and we're going to run the on notify method on it, and we're going to pass in the event. So what are you yelling me about? No method not found in score. So we need to now implement that on notify into the score. Thank you, Dark Sky, for letting me know again that something is going on. So let's go make this work. We need to add the on notify to observer, and we know that we can do that through this observer trait, which we're getting out here. Use events. Here's the observer trait. So we're going to go into score, and we're going to implement. So I guess we need to pull it in. Use super. The observer trait. So implement observer for score. Not doing like observer first subject again this time. That would be silly. Okay, and then we're just missing on notify. So function on notify. We need a mutable self. And then we have this event coming in. So we need the event also. Event. And then we're not going to really change anything. We're just going to mutate ourselves. So we saw with score, we're just going to run this increment method. So if, I guess we can do an if let here. So if let, what is it? It's going to be event player jumped over obstacle equals the event. Okay, so if that's the event that happened, then self dot increment. And that's it. That's all we're going to do for this. All right, so one error. No method named on notify found. We just created an on notify on it. So maybe it would be happier. You still can't find it. Oh, no method name for the, right, because I'm gonna have to extract it out. Right, I almost forgot about that. So we've cloned this vector, which means we cloned all of these things. I should just be able to lock dot unwrap here. And then irrefutable if let pattern, that's a warning. Used to move value event. So notify, wait, did I, oh, okay. I might want to like clone the event around. Otherwise, I'm going to need to do a reference to it and pass a reference to the event to on notify, which might work. So if I come back to our score, I guess it would be this mod here. If we say that this is really just a reference to an event, should be fine there. They're going to come to score. We're going to say that this is a reference to an event. I don't think anything else, here now needs to change. And then an obstacle, we're going to pass in a reference to the event. There we go. So then that hopefully should just work. So when a player jumps over the obstacle, it should tell the score to increment. The score increments itself, and then that should cause the score to go up. Let's see if it worked. Cargo run. The game compiled. That's a good sign there. Oh, but no, the score didn't increase. So the score's not increasing. Let's see if it's increasing behind the scenes. No, it did not. Okay. So we didn't quite get there. Let's figure out what's happening and like where things are going wrong. So in our main library, we're creating our score. Well, let's first let's just go from backwards here. Is on notify being called at all? So we'll do a print line called. And we'll just run this, and let's see whether or not we ever get that called when we jump over. No. Okay. So, we didn't get called. I suppose I need to check it for both of the objects, just in case like one of them is working and the other is not for some reason. Okay. So not working there. So it's never hitting on notify with our score. So then we move back. Who's calling on notify? That would be the obstacle here. Is calling on notify. Is this happening? So is notify being called? So print line called. I'm just gonna copy this entire line. So is the notify method being called? No, it is not. Okay. So that's a problem. Okay, so notify is not being called. Notify gets called right here. So self.notify. This is a player jumped over the obstacle. Maybe my math is wrong here. If I do this, instead of called, this is player jumped over me. No, okay. So that's not happening. Now, so we know that run is happening because this velocity and location are being updated. So we know that the obstacles are moving to the left. So run is happening definitely. Okay, so if player location X before, player get location center, dot X, if that's less than location, self.location X. So we kind of blindly made this, but we didn't get a chance to test this. So what we're trying to do is say, hey, if the center of the player before we updated the obstacle's location, if that was to the left of the center of the obstacle, and now it is to the right of the center of the obstacle, then that means that that the player jumped over us. Unfortunately, this didn't work. Let's see. If I only have this one, if I comment you out, and all we're checking here is if the player location X before. So if the player is to the left of the obstacle, we should get like a constant score going up. And there it is. Score is going up. That's the event system is working. And it's going up for both of the obstacles. Although like not for that first one. Okay, so the event system is working. It's just our math here is completely wrong. Now if I want player X before so that's player get location center. So you need a player. We have this get location center. So we get okay, so it's gonna be a point to new. And then we get the X of that, so the dot X. Get location center. When we create our player, I believe we're going from like the top left of the player rectangle. So center should be, so self.location.x plus self.width divided by 2. And as long as that's happening in the right order, that should be fine. Now, obstacle-wise, what are you? So in our create mesh, we have 0, 0, and then down into the, well, I guess for you, it's down into the left, then down into the right, and then of course it draws back to itself. back to that first point. The 0, 0 is, I believe, the center. And then self.location, location x, location.y. I mean, I would think that there should be okay. So what did I do with my math figure? Okay, so if the player location x before. So we're going to get the location center, get the specific x out of that. We're going to increase our location from our velocity. Do we need to know? We need to know if the player was to the left of us before we moved. I'm moving and then I'm checking to see it should, the player's never moving. It's the obstacle that's moving. I should probably check to see, because the player location X is never changing. I don't need to get this twice. I probably need to check to see myself, like get a clone of myself. So let's do if it's like if X before, I could just do location before, and in reality this is going to be self.location. Let's just do location x before, so .x. This will clone that, but it's an F32, so that's super cheap. Then we're going to update ourselves. And we want to say, okay, if we are to the right of the center of the player. So we don't need to get that center of the player twice. So we'll just do player location center equals player dot get location center. We update our location. We're going to have to update this entire if statement here. So if we're the obstacle, if we are to the right of the player, and then we're to the left of the player, the player has jumped over us. So if location x before, if that is greater than the player location center dot x, and now our current location, so self dot location dot x, if that is now to less than player location center dot x, then this happens. So let's save that. Let's see if this works. And I can leave in that print line, player jumped over me. I'm hoping that this just works straight off, and everything is good. Player jumped over. Oh, and the score incremented by 1 and 2. Perfect. So we've implemented the observer pattern for the obstacles here. So the score is observing both of the obstacles. The obstacles have an array, or actually a vector of these, wrapped, these observers. The observer just happens to be the score right now. Other things could potentially observe this event. I don't know if we want to anything for this right now. We can make like trees grow. We can do all sorts of interesting things. We could even implement the speed increase to this too. That might be interesting. Oh, I died. Let's jump over and make sure the other one still works for this. Jumped over 1 obstacles. Perfect. And so we can now implement the observer pattern for anything else that we need to here, because we have the pattern down. Anyways, it is 8:15. So I'm going to go ahead and get ready for the rest of my day. But I hope that this was helpful for you. I'm gonna go ahead and push up all this code. So let me do that right now. Close all these windows just in case I have anything unsaved. Now come over here, update you, and this score is now observing the obstacles for the player so that the score can increment itself when the player jumps over the obstacle. I'll push that up. And then once again, for those of you who are here live, if we do bang repo, there is a link to where the code is. I'll also put the code into the video description. So in case you want to go and take a look at this, clone it down, or anything else, feel free to. If there's any issues or anything else, you can post, add an issue to GitHub. Or if you want to fork and do a pull request or anything else, that absolutely, I'd love to see those. So with that, I'm doing these streams every single weekday morning when I can. So it's should be every week this week at around 7 a.m. Mountain Time. I do it for about an hour and 15 minutes or so until about this time, and then I have to go to work and do the normal thing. So with that, hope that you have a great June, a great week, and I shall see you next time.